We're looking at a way to find equivalent fraction with the help of multiplication. So the basic idea is when we multiply both the part of the fraction, that is your, both the part means numerator and denominator, by the same number, we are zooming into the process of selection and also division without changing the size. Like making smaller pieces of the same chickpea but keeping the total amount the same. Don't worry, we'll understand this. Why do we need this? Equivalent fractions is needed to compare for addition, for subtraction of fractions. For very fundamental, further new aspect of fractions, we need to learn how we can figure out equivalent fractions. Okay, let's take up an example. So we have 2 by 5. So I'm going to multiply both the numerator and denominator with 3. Again, it depends. Why should we multiply with 3? It can be even 4 also, it can be 5 also. It depends. It depends on the scenario. That scenario you will understand in the next section. So if I multiply the numerator 2 with 3, I'll get 6. If I take up the denominator 5 and multiply with 3, I'll get 15. And so 2 by 5 is same as 6 by 15. I can do with any number. Okay, so 2 by 5. I can multiply the numerator with say 4. And the denominator also should be multiplied with 4. And 2 times 4 is 8. And 5 times 4 is 20. So 2 by 5 same as 8 by 20. Okay guys, so let's examine why. That's the most important part. Okay, so let me I made some space over here. Imagine a chickpea. So we have a single piece of chickpea divided into 5 equal parts and you take 2. Thus giving you 2 by 5 of the chickpea. Now divide each of the 5 parts into 3 smaller pieces. You now have 15 tiny parts in total and you still take 6 of them. That is 6 by 15. So let's examine all of this. So let me take up the first case. First case is we have 5. Originally we had this entire piece. Let me do this. So originally we have this. This is the original case. So when it came from the factory, or if someone made in your place, they would have made it as a single piece. Now, there are 5 of you guys, grandparents and you, and say your dad is not eating, right? And you and your brother or sister are eating, and so on and so forth. So there are 5 people. I have to divide by 5 parts. And I did that. So this is what? Dividing into 5 parts. Now, we got to, you got 2 pieces. So you got, not this, this is what we're dealing with, 2 pieces. So let me select 2 for you guys. So you guys end up doing this, but you find out that, these are too big for you to consume at one go. It's better to divide further, make it to smaller pieces. So let us make it to smaller pieces, right? So this is a different scenario. That piece you ate. So now you are dividing into 15 pieces. But of course, whatever you ate last time, you want to eat the same. So I want to see to that the amount of eating or the amount of chickpea that I get is same. So I think we're almost there. And one more small piece and the quantity looks the same. So here I think the quantity looks the same. So let me verify this. Can you see that? The quantity looks the same. Okay, let me do this. Okay, perfect. So this is second case. So another chicky piece, and this is what has happened. So can you see that you end up eating the same quantity, right? 2 by 5 is same as 6 by 15. Okay, so yeah, let me actually I do want to write few more things. Let me write it over here. 2 by 5, we happen to see that it is equal to 6 by 15. How? By multiplying the numerator with 3 and denominator with 3. Now, what is the logic behind it? Well, when I divide into 3, that is, this means that we are further dividing each part into 3 more equal pieces. So let me show that with this example. So if I take up each of this, we can clearly see that they are equal sized. Is it not? Let me rearrange this a bit. Can you see that they are equal size? Just that the divisions are different. That's it. So this is what multiplying 3 with the denominator does. It further subdivides the parts. So these are one and the same. These are one and the same. These two are one and the same. While the one in the numerator, okay, it's like selecting 3 times more whatever you are selected. So this is select 3 times more the same number of pieces. I'm not very happy with the language actually. Select 3 times more. Okay, just let me stick to this. So whatever you originally selected, that you do it 3 more times. So basically, instead of 2, I'll be going with 2 plus 2 plus 2. That is 6 times. And that ends up giving us the same amount. Okay, so that's how all of this works. So originally I selected 2 and I have to do it 3 more times. So whatever I did originally, that I have to do it 3 more times. Same number. I think that is a bit better. Okay, so what is that we are looking at? We are looking at figuring out equivalent fraction using the method of multiplication. All you have to do is, given any fraction like say 10 by 13, all I have to do is take up the same set of number, numerator and denominator, multiply with any number like say 3, but the same number has to be multiplied with the numerator as well. And on multiplying, whatever we get, that is your equivalent fraction to the original number. So why does this work? Well, when I multiply the denominator with a particular number, we are further subdividing it. We are further dividing the parts into that many equal parts. And the numerator multiplication lets you select the same amount. Right? So that you got to see. And here we have one more example. Yes, you can copy this. We'll do few set of questions, then you will get a good grip on the concept, on the methodology.